we're going to be talking about something called like grid counting. So grid counting is like a very like common type of counting problem that appears pretty frequently on the AMC8. So today we're going to talk about like ways to like solve these kinds of problems, since like it's really important to like know how to solve these problems. So first let's talk about like what do I mean by grid counting? Like, what does grid counting mean? So basically what a typical grid counting question is like, let's say you have like some grid, and then maybe you have like a person or something. Like a person is like standing at this point, like at this bottom left corner, right? And the person wants to walk. And on each step, the person is going to either take one step to the right, or the person is going to take one step up. So from this current position, the person can move to this point here, or they can move to this point here. And a very classic problem will say, well, if the person can only move right and up, how many ways can the person go from this bottom left corner to maybe say this top right corner here? And this is basically what a grid counting problem is. It's basically you have a grid and you want to know how many ways are there to get from one point to another. Sometimes there might be restrictions to make it more complicated and things like that. So today we're just going to be talking about ways to like solve these problems. So let's just look at a very basic example just to help us get a feel for what these grid counting problems really mean. So let's take a look. So let's suppose we had like a person and we had like a 1x2 grid. So this is a very small grid, right? So it's like a 1x2 grid. And let's say you have a person standing here at the point 0, 0, or you can just think of it as the bottom left corner. And they can only move left or right and up. And we want to know how many ways the person can get to the top right corner of the grid. So clearly, this problem isn't really like a hard problem because this is like a very small example. Like we can clearly just list out all of the possibilities. But this is just mainly to get a feel for what these grid counting problems mean. So one possible way for the person to get from the bottom left corner to the top right corner is the person can move 2 times to the right and then move 1 time up. So that's one way to get to that point. Another way is to go right, then go up, and then go right. So that's like the blue path. That's another possible path. And the person could also go up and then go right 2 times. That's the green path. So in this case, we clearly see there are a total of 3 possible ways for the person to go from the bottom left corner to the top right corner. So the answer in this case would be 3. And the reason, like, this clearly in this case, the numbers are really small, right? Like it was really easy just to list all of the possibilities out. So like, but this is basically like the very basic kind of example on what a grid counting problem would be. But clearly, like once we get to like larger numbers, like for example, if we have like a bigger grid, like this grid, for example, like, you know, a 4x5 grid, we clearly cannot like just list out all the possibilities, the number of ways to get from the bottom left corner to the top right corner, right? There are way too many possibilities. You can't say, oh, like this is one possibility, this is another possibility or something, this is another possibility. Like there'll be way too many like possible paths that it's going to be too hard to count just by hand. So that's why we're going to be talking about like some strategies on how we can organize our counting. So the first strategy that we're going to talk about is called recursion. So the idea is we can kind of like break this big problem into like smaller sub problems, smaller, easier problems to work with. So let's say we had like a kind of like a bigger grid. So let's say we had like a 4x3 grid, for example. So let's say we start at the bottom left corner, and on each move, we can take 1 step to the right, or we can take 1 step up. And we want to get to this this top right corner here. And we want to know how many ways are there to get from the bottom left corner to the top right corner. So like to do this problem, the idea is like the very like classic strategy for these kinds of questions is notice that like in order to get to this top point here, we must have either came from this blue point and then moved to the right, or we must have came from this red point and moved up. So those are the only two possibilities, right? Any path on this grid must pass through this blue point and then go right, or it must pass through this red point and go up. So basically what we can see is that the number of ways to get to this top right corner here is simply the number of ways to get to this blue point plus the number of ways to get to this red point. So this is like the idea of like recursion, which is if you want to find the number of ways to get to like one specific point, that's equal to the sum of the number of ways to get to these like this blue point, this red point, which are kind of like smaller sub problems. They're like the same problem, but with like smaller numbers, if that makes sense. So the idea is, so hopefully this will make more sense when we like start like actually doing the calculations. So basically, let's first take a look at like this bottom left corner here. So at this bottom left corner, let's take a look at like this blue point here, right? So clearly to get to this blue point, there's only like one way to get to that blue point. That's just by moving right, right? So we can like write the number 1 there just to represent that there's only one way to get to that blue point. And like, let's take a look at this red point up here. Clearly, again, there's only one way to get to that red point, right? You can only just move up 1 unit. So we can just write a 1 there. And by similar logic, for example, this point, there's only one way to get there, right? You can only move right 2 units. So we can write 1 here. And similarly, for all of these points, there's only one way, right? All of these blue points, you have to just keep moving right. That's the only way to get to those points. And similarly, for these red points, there's only one way to get to these points. Now, let's take a look at, how about this point, this green point here, which is a little more interesting. Like, how many ways can we get to that green point? Well, clearly, we could just count them, right? Like, there's one way there, or you can go like this. That's 2 possible ways in total. But a better way to look at this is notice that in order to get to this green point, we must have came from this red point and moved right, or we must have came from this blue point and moved up. So those are the only 2 possibilities. And we know that there is one way to get to this red point. So there's one way to get to the green point from the red point. And we know that there's one way to get to this blue point. So there's only one way to move from the blue point to the green point. So we just do 1 plus 1, and we get that there are 2 ways to get to this green point here. So that's kind of like the idea of recursion. You're using like smaller numbers to build up to this larger case here. So we can kind of use similar logic, right? Let's take a look at this yellow point here. So clearly for this yellow point, you must have either came from this green point and moved right, or you must have came from this blue point and you moved up. So notice we already know that there are exactly 2 ways to get to this green point. So that means there are 2 ways to move from the green point to the yellow point. And we know that there's exactly one way to get to this blue point. So there's exactly one way to move from the blue point to the yellow point. So then that means this yellow point, there are 3 ways to get there. And basically, we can kind of start noticing a pattern, which is like any point. We noticed that this 3 was kind of like 2 plus 1. And we found that this like 2 was kind of 1 plus 1. So in general, like, for example, for this red point here, this red point here is going to be the sum of the number of ways from the yellow point and the green point. So this red point is going to be 3 plus 1, which is going to be 4. It tells us there are 4 ways to get to the red point. And for this red point, you just do 4 plus 1, and there are 5 ways to get to that red point. And then we can kind of continue applying this similar logic. So for this point here, we know that we would just do 1 plus 2, which is 3. And for this point here, we would just do 1 plus 3, and we get 4. And if we were to keep doing the math, so here it would just be 3 plus 3, which is 6. Here would be 4 plus 6 is 10. This would be 6 plus 4 is 10. This would be 10 plus 5, which is 15. This would be 10 plus 10, which is 20. And finally, this point here, you would just do 20 plus 15, which you would get 35. So that tells us there are 35 ways to move from the bottom left corner all the way up to the top right corner in this grid. And this is how you would kind of like use recursion to solve the problem. We kind of started from like smaller cases and we built our way up to like this final answer.